Good morning, student. I hope you are feeling better at home. Today, we'll take your lesson number or chapter number 16, which is probability, and your topic is some useful random experiment. As you know, what is a random experiment? An experiment is said to be random if all the possible outcomes are known, but exact which one come first we cannot predict in advance. That one is called random experiment. For example, tossing a coin or throwing a die. Okay, in this we have already discussed tossing a coin, what will be the possible outcomes, and second, tossing two coins simultaneously, then possible outcomes will be four. Okay, and third one, throwing a die, then our possible outcomes will be 6, which is 1, 2, 3, 4, 5, 6. Okay, now fourth one, throwing two dice. Okay, throwing two dice at a time, or tossing two die dice. Okay, then possible outcomes will be 36. Possible outcomes equal to 36. And our sample space, what is our sample space? Okay, so sample space, yes. Okay, to just like 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 2 1, 2 2, 2 3, 2 4, 2 5, 2 6, 3 1, 3 2, 3 3, 3 4, 3 5, 3 6, 4 1, 4 2, 4 3, 4 4, 4 5, 4 6. Okay, and then 5 1, 5 2, 5 3, 5 4, 5 5, 5 6, 6 1, 6 2, 6 3, 6 4, 6 5, 6 5, 6 6. So these are the total 36 possible outcomes when two dice thrown or tossed together, and elements like 6 6, 55443311 that are called diagonal elements. Diagonal elements. So element like 112233445566, that one are called diagonal elements. Okay. So now next topic, impossible event. Impossible event. And a event is said to be impossible, okay, or we can define the let S be the sample space if phi is subset of S, then such a type of event is known as uh, impossible event. Phi is called impossible event. It means if we try to understand impossible event by an example, then we can say that when we tossing a coin, then what is the probability of getting two? So, as we know that when we toss a coin, then only two possibility, either it will be head or it will be tail, but two cannot come. So, here our favorable outcomes will be phi. Okay, and as we know that phi is the subset of every set, so we can say that phi is subset of our sample space. So in this case, it is impossible event. So another example, if we throw a die, and what is the probability of getting it? As we know that when we throw a dice, then we get one, two, three, four, five, or six, but we cannot find eight. So here we cannot find our favorable outcomes. It means it is five. So it is called impossible event. Okay. Next, sure event. Sure event. If whole sample space is our favorable outcomes, then such an event is known as a sure event. Let S be a sample space and if S yes is subset of yes, then we can say that yes is our sure event, or we can say that if total number of favorable outcomes is equal to total number of possible outcomes, then such type of event is known as sure event, and the probability of sure event is always 1. Okay, the probability of sure event is always 1, and the probability of impossible event is always 0. Okay, next topic. What is probability? Okay, let yes be a, or we can say that let E be an event. Okay, then probability of any event equal to number of favorable outcomes, are event, okay, upon total number of total number of possible outcomes are event. Okay, so probability of any event is greater or equal to 0, less or equal to 1. It means probability of any event lies between 0 to 1. So the event whose probability is 0 is called impossible event. Okay, impossible event, as we earlier told. Okay, and any event whose probability is equal to 1, and that one is called sure event. Sure event. And rest event, their probabilities lies between 0 and 1, and the probability of any event cannot be more than 1, either cannot be in negative. Okay, it will lies between 0 and 1. If any event whose probability is 0, that one is called impossible event, and any event whose probability is equal to 1, that one is called sure event. Thank you for watching.